continuing on with yesterday and resume meet. So we have a website for you guys to write summaries and submit them of the projects we've worked on. So what did we get up to yesterday? We did front-end authentication, right? So a user is able to fill out this form, and when they click register, the request is going to the backend. The backend is making a token, sending it to us, and then we're storing that token. Let's draw out what that looks like one more time. So here's our client. Here's our server. So if a user wants to register, what does that request look like? What does that request look like? Ketzerin.
Sorry, not sure about that.
Yeah, what type of request is it? What path is it? What type of request? What information do they send? Daniel?
It's a GET request, and we send over the username and password.
It's actually going to be a post request. Do you know what the path is going to be?
Post users.
Yeah, user/register we're going to do. Whoops. And then the information, like Daniel said, we're going to have to provide is the username and password. And then eventually the server returns us what? What does the server give back to us? Jiang?
It will be back to us a JSON, set, truth, and token.
Yeah. And specifically, it'll look like this. So I'm going to mute you real quick, Jiang. Sorry. Yeah. So that's the response, right? So we haven't talked about what does the server do when it receives, what does the server need to do when it receives this request? Can anyone think of any steps it probably needs to do?
It needs to generate the token.
Yeah, it will have to generate a token. Even before it does that, what does it have to check about the username?
If it's a repeat.
Yeah, check if user already exists, because it doesn't want to create the user twice. Generate a token. And there's like a final thing it needs to do. You're doing helium mic again, Victor. Yeah, I couldn't even understand. Kimberly, what is our third piece in the puzzle? What is the third major piece of full stack applications?
I don't know.
The database. So what do you think the server needs to request the database to do for this process of registering a user? What does this relationship look like, a request? What's your guess?
Does it need to store it? So
yeah, the server needs to ask the database to store it. And what language or what tool do we use to ask the database to do stuff from our server? What's the
Prisma.
glue? Go ahead.
Prisma?
Yeah. And do you remember the method on the Prisma object to ask it to create a user?
It wouldn't be just .create, right? Create.
Almost. First our model and then create. Yeah. So that's how the server is going to request it to the database. And then the database, we don't really care how the database does its magic. We just know it works, right? What does the database send back the server, though? That we do care about. What does that look like? If we ask the database to create a user with username and password, what does it give it back to us?
Does it give
a
you?
JSON?
I think it actually if we're using, so I don't know what the actual database gives us, but Prisma will convert that to an object if we're using Prisma with JavaScript. So we get an object. What properties do we get back though? We get one for free, which is cool.
Success, true, the
Yeah.
username, ID.
Yeah, so we get back, where is it? Oh, doing that? Yeah, we get back something that looks like this from the database, but also an ID as well. Yeah. And that ID is like a UID, so it's all crazy. So anyway, we've been relying on my backend I built. But now today we're going to build our own backend. Oh, here, let me fill this out. Ask database to create a user. Prisma. So we started creating our own database. Well, we created our own database and server yesterday, right? And we got as far as doing two tables or models of summary and user. And also our first like real request for summaries. And that's as far as we made it in our backend. But today I want to be able to do a register request. So I no longer want to use the backend I created. I want to use the locally running server. How can I point this front end to talk to the local server? Ronald? What's the address of my locally running server? This one.
Localhost 3000.
Yeah. Hold on. Does that look weird? Did I forget something? Slashes or?
Yeah, 2/
Like that?
Yeah.
Okay. All right. So now this is going to break, right? So this functionality that we had before, let's see what errors we get in the console actually. Well, here's the first one we can work through. Maybe Ryan can help us out with this one. Access to fetch has been blocked by CORS policy. So it's trying to make a request immediately to probably get, well, it's doing a couple things. It's making this fetch request. And that's it actually right now. So it's just making this fetch request, but it's being blocked. So what can we do about that, Ryan?
Yeah. npm I cores.
Yeah, so we go over to our backend and we install cores. And then we can use it as a middleware. And can I auto import it? No. And now if I run this again, will we have that error? No. But we also don't have, we also lost our ability to register a user. Because we're sending this request to our database, our server, the locally running one, and it has no route found. So our job today is to make a route. So how can we get started making a route to respond to a post request to /users/register? Renata, how can we start working on responding to that request from our backend?
Sorry, I don't know.
Okay. Open to the class. Any ideas?
Is it app.post?
Do I want to move this here? Yes. App.post. And what is the first argument, Daniel?
The path that you wanted, that you put up there, so users/register.
Yep.
And then
And
you're
we'll
gonna want
start
the
with a callback function, gets rec and res. And first, I just want to see, just a sanity check. Will post a user. Or maybe I'll respond.send this as an object. So I'll copy this one. So right now we'll post a user. There's a lot of work we have to do, but let's just see if we can get this working, right? And then I'm not sure why I moved this over here. I don't want it over here. Give me 1 second. Apps.jsx, yeah. And then how can I test this route? This route right here. How can I test that route? Renata, any ideas there? How can I test this route I just created using Thunder Client? What has to change here?
Post.
Yep.
And I guess it's users
/register.
/register.
Yeah. And what are we expecting to see when we send this request?
Success true.
And
I'm not sure.
right here. Yeah.
Yes,
we'll
just that whole
post a
piece
user.
there. The message will post
Yeah.
a user. Yes.
There we go. So it's working. That's nice. What does the user have to provide me to register a user? What were they providing us from the front end when we worked on it? Ryan?
Username and password.
Yeah, so let's do that. And let's give it a username. Whoops. And password. I wish I still had that format option that they took away from me. So I send this request now and I still get will post a user. That's fine. How can I see? I want to make sure I can receive this username and password in this callback. How can I just see this username and password in the console here? Monica?
How can you see the username and password?
Yeah, I want to see the username and password right here from Thunder Client request. How can I access the information that Thunder Client is trying to send me in this client request?
I don't remember.
Okay. Hara? What do you think?
Can you console log the user
That's what I want to do. I want a console.log username
name, password?
and password, but is that going to work just like that? No, right? Error is username is not defined. So how do we access something that the user sends us in a body in our server in the backend?
And rec body.
Rec.body,
Yeah.
yeah.
So we're going to destructure both of these from rec.body. And now when we console.log this, we should be good. Or actually, we won't be good. Does anyone know why?
Because we didn't put it in the res.send, or
We're sending it in the body here, and we're destructuring it from body here, and we're console.logging it. But I got cannot destructure property of undefined. Why is my...
JSON.
Yeah, so we have to do a little homework. We have to tell
right.
Express we're expecting some JSON. Please convert it to an object for me. Now, Ryan password. Great. So what is next? So next is asking, well, next, I guess, check if the user already exists, right? How can I do that? How can I'm going to do like a check user, but how can I ask the database if this user already exists? How do we communicate with the database at all?
Is it we use Prisma but fine with fine?
Close.
I don't know. Yeah.
Prisma dot. We have two options here:
Find
summary or user. Yeah. What do you think, Roman?
user find
Yeah.
unique?
Dot. Find. Which one?
Unique.
Sure. And then here, if we forget, it gives us an example. So I'm going to do an object with where. What should be in my where? Zach, any ideas? What should I put in my where here?
Are you going to be putting something like telling the computer what the ID of the user would be?
Yeah, but we don't have an ID. Usually we would use ID, but in this route, we don't have an ID.
Would you use the rec then?
No. Yeah.
I'm not sure.
But there is something unique we do have that we can use.
Username?
Yeah, we're going to use the username in this case. And then let's console.log check user. See what that looks like. So what did we get? We got a promise. So what did I forget to do?
Benuit.
Yeah. All right, try again. And we got null. Is that good or bad that we got null? Or what does that mean in this case? Monica, what do you think null means for this response?
Like it wasn't passed correctly, or?
No, I don't think so. I think it was correct. So we're asking Prisma to find a user and it's returning null. What does that communicate to us?
There's no user.
Yeah, no user, which is great. So we're good there. So we checked if a user exists. So now, well, let's actually put a user in, because that'll be more fun for right now. So we're going to use Prisma Studio to put Ryan in so that we can actually get an error, because we want an error in this case. So let's add, we had Daniel. We could just use Daniel, I guess. Whatever. So Ryan, 1, 2, 3. Daniel and Ryan both don't have passwords. There we go. Okay, so now when I do this request, let's see what check user looks like, right? Let me rerun our server. So now check user, I get an object back with Ryan's user ID. So if check user is truthy, what do you think we want to respond to the user?
Success false and the message with like user already exists.
Yeah. So success false. Username already exists. Please log in. So now Ryan forgets that he was registered and he gets this nice message, right? I mean, really, this would be the front end developer getting this message, but then they would take that message and display it nicely for Ryan. So if we reach this point in the code, we know there's no Ryan user. So what do we want to do at this point? What do? What did we say our steps were? We'll worry about generating token in a bit, but we're going to do this step. Ask the database to create a user. So how can we ask the database to create a user? Jazz?
No.
How do we ask the database to do anything ever?
You ask 1 second, sorry.
It'll be similar to line 23.
Okay. You create a variable and then await prisma.user and create.
And then if we forget how to use create, there's a nice example. So lead me through it, Chaz.
Okay. And then inside that, you put inside that curly braces.
An object, yep.
And then, yeah, an object and then data.
Which in itself is an object. And then what should we put as data? What does it need to create a...
You need the username.
And
the password.
Yeah. And then here, instead of message, what do you think we should send, Jazz? So the front end developers knows this was successful.
User created successfully.
Sorry. Well, yeah. Or I don't know. You could do that, I guess. But I think it's more powerful just to show the actual user that was created.
Okay.
Yeah. Okay. So let's try to do this, right? Ryan, password 123, but username already exists. So he wants to do an alias of Ryan2. And we got success true user. And this looks great, except it doesn't look totally great. It's kind of bad security wise. What shouldn't we be sending the front end developer? They really have no business needing this.
Password.
Yeah. So how can we remove that password before we send it? We saw this once for 10 seconds a month ago. Or not a month ago, but 3 weeks ago. How do we delete a property from an object? And I said, we'll never use it, so it doesn't matter. Here we are using it. Yeah, we can just delete it. So we send this again, but we'll get an error. So we do Ryan 3. And there we go. That's much nicer. No, they really don't need the password. But now we've possibly violated European law. Not to be dramatic. Does anyone know why? I don't think US law yet, but we've possibly violated that EULA law. Does anyone know why?
Is it to do with the storage of the password?
Yeah. This is called a plain text password. Plain text password. Bad and never. Why? Why should we never store a plain text password?
In case it gets hacked.
Yeah.
Or leaked.
If it gets hacked, I mean, this can be a rhetorical question. How many people reuse the same password, right? Everyone, probably. So, if it gets hacked, now the hacker has access to like every site you use. How about if it doesn't get hacked? What would be another problem of using plain text passwords?
The administrator can see them.
Yeah. Does everyone here trust their ex who works at Google or Facebook with their passwords for everything? So even we developers shouldn't be trusted with users' passwords because we're just people who can abuse it as well. My favorite site, I always show students this. It's kind of funny. Plain text offenders. So these are developers who included plain text passwords in their databases, and there's a whole website to shame them, right? So here's the latest one, I guess. I don't know how active these people are. Like, look, they have a Tumblr link, so I doubt they're that active. But I'm sure this goes on every day. Why are they on this website, though? How do we know that Shodan... What is Shodan? Does anyone know? Anyway? How do we know that this developer screwed up or this whole company screwed up? Why are they being shamed?
Because they're asking. Yeah.
What? Presumably here is
They're
a username
asking-
and a password in plain text. And they sent this customer an email, but what shouldn't they even have access to, really?
Password?
Yeah, they shouldn't even be able to have access to the password themselves. But they do because they sent it in an email. I wonder if there's any big names here. Nah. Xbox? Or that's a fake Xbox, I guess. Yeah, I don't know. Does anyone recognize any of these? Probably not. Sneaky Santa. I don't know. Maybe this is dangerous to browse. But anyway, you get the point, right? So what can we do about that? We don't want to use plain text passwords. So we have to do something called hash the password before placing it in the database. So we take that plain text password and we hash it. Whoops. And then it's all scrambled up looking. So text goes in and crazy text comes out. But there's a whole rule about hashing functions, how they operate. I think the most important for you guys to realize rules for hashing. The number one most important is if it's the same input, will produce same exact output. The other rules are 2 different inputs must produce 2 unique outputs. Those are going to be the rules that are important for our cases. But here's the weird part, right? So if Ryan puts in his password as pass123 and we hash it before placing it in our database and it becomes some gobbledygook and we put this gobbledygook in our database, Ryan now goes to log in again. How do we know he's the right user? Because this is all we have. We don't have his password here. So this is stored in database. But now Ryan comes again and gives us pass123. We don't have this in our database. Is he the right user? Or is he the authorized user? The authenticated user? So why is hashing valuable for us as developers if we don't even store the password?
For identification?
Yeah, but what do we need to do when so Ryan registers, we hash his password, place the gobbledygook in our database. He comes back a week later and gives us pass123. We don't have any record of that in our database. So what do we have to do again?
Hash that password.
Hash the password, the plain password again, and see if it matches what's stored in our database. And that's how we know if he's legit. And this is a way that we never have to store his plain text password. We can always just rehash it. So before I get to this step of creating the user, how do we hash the password? What library do we use? Because this is really complicated math. We're not going to build this ourselves. We're going to rely on someone else's code. So what library do we use to do this?
Is it going to be a node module?
It is, yeah. But which one?
Bcrypt.
Yeah, so we're going to use something called Bcrypt. So we have to go ahead and install it. And then we can check out their docs. See if there's a little example. So they have the old callback function. We're going to use async await. Do they have the newest? Oh, here it is. Not really. Here they go. Finally. I think this is good for us. No, still too much. Anyway, I'll show you the easiest way to do this. So we don't want to look at that. So we want to import Bcrypt. I don't know why I can't auto import it. It's kind of annoying. So here I'm going to do bcrypt dot hash. And this actually returns a promise. So I'm going to await it. And then inside here, what does it require? So it says the first thing is data. So that's like the plain text password. So I'm going to put in, actually, I'm not going to put in hash password. What do I put in here? Where's my plain text password stored? Rodrigo, any idea? Where's my plain text password stored right now?
In the database?
In the what?
Sitting in the database?
Sitting in the database. No, not yet. On this line of code, not yet. Not yet.
User?
Or
Not user, no.
you plucked it from the body, right?
Yeah.
Password?
This password, yeah. So we put in that password, and then it needs another argument called assault, rounds of salting. So then the question is, what is salting? So if our story of hashing plain text passwords only made it this far, so Ryan comes with pass 123 and it becomes this, right? But then Daniel also has the password 123. What is that going to hash to?
It will be the same. Isn't it?
Yeah, because of the rules of our hashing functions, the same input produces the same exact output. So now Daniel and Ryan both have the same hash. Is there a problem to this? And security-wise?
Yes.
Yeah, so people can take the most popular user passwords, top 100 passwords. I don't need 10 million. Jesus. Anyway, here's some of the most popular passwords right now. And they can hash them themselves. And then when the database is hacked and they know your hash, they can just match this up. It's called rainbow tables? Rainbow tables? Is it not called rainbow tables? What is this called? Rainbow table hashes? Yeah, here it is, kind of. Yeah, so people have computed the passwords of very popular passwords, although this is not popular passwords. Top 100 passwords with hash, with MD5 hashes. I don't know. I can't find this right now. Let me try one more time. Rainbow table hashes top common. Here we go. Finally, Jesus. So they've taken the most common passwords and they've used a hash algorithm to compute them. And then when they hack this from the database, they know your password. So how does salting... So salting is what? Does anyone know from the pre-work? You can be a fine developer without understanding this in depth, but it is really interesting, at least to me. So it's worth 2 minutes.
Switches it around.
So it's gonna add a random string before it hashes the user's password to avoid rainbow table attacks. Because now, even if Daniel and Ryan both give me pass 123, I add the string blah, 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 blah randomly before it. And now I'm getting hashed something different from both of them, even though they have the same password. And salting is referring to doing this many times. I think this is 2 to the 10 times doing this process. So, yeah, that's hashing. Let's take a look at the hash password, see what it looks like. Excuse me. So now instead of password, what do I want to give Prisma?
Hashed password?
Yeah. So we don't get shamed by plain text offenders. And now I send this, I get an error that he already exists, right? So Ryan 4. Oh, we don't get to see the password because, yeah. Let me comment this line out just so we can see it. Will be fun. So Ryan 5. So now, the salt is like the first. Well, no, this is like the version of Bcrypt. Blah blah blah. Maybe this is the salt, and then this is the hash. Doesn't really matter for our use case. This is what we get back from Bcrypt. What questions do you have on this process of hashing a password?
So the salting would be the number 10 after password.
No, the salting is a random string that's added before it's hashed to prevent the same users with the same passwords having the same hashes and being able to predict.
Automatic?
What?
So it's automatic. We'll have
Yeah, you don't have to worry about it at all. Bcrypt does all that for you.
Okay, thanks.
Yeah. Yeah, you just have to use this.
But on line 35, like after the argument, like it's always 10.
Line 35. No.
After
This is how powerful you want your hash to be. So how hard does a computer have to work to generate the hash? You want a hash that doesn't take too long because then your user experience sucks. But if you don't want it too short because then a bad actor can hack the password by generating millions and trillions, or maybe not trillions, millions and billions of these hashes. So your normal computer, how many hashes do you think it can produce every second?
a lot.
Doesn't it depend on the computer?
Yeah, but a normal like gaming computer, let's say.
Like 100,000. I don't know.
Okay, 100,000. Let's see.
Millions.
Yeah, I think millions. How many hashes can my computer do? I don't know. Oh, only 65,000. But that's the really powerful one. SHA-256. I don't know. It's a lot. How many hashes can NVIDIA RTX do? I don't know what MH millions. I don't know what that means. It's a lot. It doesn't really matter. Yeah, so that's salting. Other questions? Okay. So, what do we still need to do though? What work do we still have left to do? We've created a user in the database. What did we say our other steps were for our server to do? What's left? Alex, what's left to do for our server?
Generate the token.
Yeah. So now we have to talk about what a token is, right? So what is a JWT? What did you guys get from the pre-work? Victor, did you have a chance to watch that video?
I did, but I can't remember right now.
You remember anything comes to mind about a JWT? If not, that's fine. It's hard.
Yeah, no.
So here it's telling us representing claims securely between two parties. That really doesn't tell us anything, right? It's a string, so we can start there. It's a string that has 3 parts. I think that's a good way to break it down. So what are these 3 parts, right? First part encoded algorithm that was used to produce it. Second part is the payload, encoded payload. And third part is probably the most interesting, the signature. So I really don't know how in depth to go with you guys on this, but this is the part that we care about. Here we can put in this token anything we want. And what we're always going to do is put the user's ID. So, oh, I already screwed it up. So this is JSON, right? So I need to do JSON. So here, now this string, this middle part is actually encoded this object in base64. So we're going to take users' information and make it into a token that they're going to store on their computer and present to us again. The interesting part is this signature, which basically means if signature is valid, we know that it came from our server and no one else. That's the usefulness of this token. So when a user presents us the token, anybody in the world can see the information. It's just encoded. It's not encrypted, which even other instructors get wrong. So it's not secret. So you never put a password in a JWT. The use is that when it comes back to the server, we can test it and know that it came from us and hasn't been manipulated. And no one else manipulated it. So that's kind of the very surface level of a JWT. And that's all we need to know for our use case. So here, we want to generate the JWT. So does anyone remember from the pre-work, how do we generate a JWT?
You need to install the JWT.
Yeah, the package is going to be called JSON Web Token. But we're going to import it and call it JWT from JSON Web Token. And then here, this is pretty nice and easy. We just do JWT.sign. And the arguments, the only arguments we need to give it are, well, there's two important ones. The payload. So again, what is our payload? This is the encoded payload where we store the user's ID as an object. So here I'm going to do something like pass in an object with an ID. How do I access my user's ID though? Let me actually call this user ID so there's no ambiguity. Yeah. Where can I access the user I created's ID?
Is it in const user?
It is, yeah. So user dot
ID.
Yep. And honestly, I think that's all you need in your JW. Maybe we'll put the username. I guess that doesn't hurt. Do we need to though? No, I don't think we need to. And if we don't need to, why do it? Because when the user has a token, they're going to immediately send a request to the server to get the user information. So I don't think we need to. I don't know. We'll come back to it if we do. So now what should I send in? So let me save this into a variable called token. I can't remember if it's a promise or not, so we won't right now. And then what should I send in the response to the user? And come to think of it, what should I what should I take out of this response so it matches the docs? And what should I add?
Take out user and add token.
Yeah, I actually don't want to send the user in this particular response according to these docs, which I didn't even realize as I was doing this. So anyway, Ryan 5, we got to run the server. He already exists. So Ryan 6. Oh, we have an error. Secret or private key must have a value. So the second argument we need to provide is our server's signing secret. So here we'll create a new environment variable called JWT secret. And here you can kind of just finger smash, or if you want to do this more properly, there's a crypto library. You can generate some crazy string. But for our purposes, just finger smash a bunch is probably fine. Anyway, this now is our server's, this is how we sign the tokens. And when they come back to us, we know that they're our tokens. So if anyone else has this, they could do anything. They could sign tokens that then your server thinks are authentic. So if I somehow got Google's JWT secret, I could then log in as anyone I want to Google if Google uses JWT, which I have no idea. So now here, how can I access something I stored in .env from my code here?
Does that have to not that JWT secret doesn't have to be a string? It could be just finger smash.
Oh no, this is a string. When we're in an environment variable, you don't need to put quotes to make a string, but you can if you want. Yeah. So back in here, how do I access something from my .env file? Which
Does it need to be imported?
DOT,
It's
ENV.
actually, one more time, Kimberly?
DOT, ENV.
Yeah, we actually need, so we are going to use process.env. The name that we created is going to be how we access it. We're not going to import it, which is weird. But here, there's a little more work we need to do. I think we're still going to get an error. Yeah. So basically, this is coming up undefined for us right now. If we console.log this. Let me show that right here. Token is not, oh, no, that's not the error. Never mind. Anyway, we have to use a package called .env so that we can access our secrets. Remember, the environment variables are to access our secrets and passwords in our normal code. So we use this package .env. And then at the very top, I haven't done this with the new syntax, so this is kind of interesting. Let's see if I can figure it out. .env from .env. And then immediately we run .env.config. And I think that's all we have to do. And then let's try to run this again. Token is not defined. Oh. This I can just take out for now. Oh, this worked though, see? So now we have access to what we wrote in here because of this .env library. And now we can uncomment this and put this back as token. And I think we're good to go. I think we were on Roman maybe. Okay, still have an error, right? Secret or private key must have a value. Huh. When we... Oh, my bad. This isn't... What am I doing? This isn't an object. The first argument is an object. The second argument is a string. My bad. Yeah. So you see my error there? First argument, object. Second argument to this sign method is a string. So we'll probably do Roman again. Username already exists. So that's... Okay, yeah. So let's do Roman 2. And after all that work and all those bugs, finally, we got back a token. So now we've successfully, the user has sent us a request to register, and we've sent them back a token. And then think back to yesterday when we used that token in the front end to do all the fancy stuff, right? So now you've seen... Yeah, go ahead.
Since on line 45, since you're no longer sending back the user and the response, we don't need to delete the password anymore, or do we?
Yeah, correct. We can get rid of that.
Okay.
Yeah, good point. So not too much code we wrote, but very important and deep concepts. What questions are there thus far?
Actually, that process.env, we do need to import that package, right? I think that's previously why I tried to do like transport to whatever, and it wasn't changing, and I was like, okay, I have the env set to this, but that makes sense. I had a point variable.
So you know what I thought Prisma. So I thought Prisma installed this package for us automatically, honestly. That's why I wasn't showing it to you guys, because I thought we got away with Prisma doing it for us, but I guess not. So
yeah, that's what I thought too.
Yeah. So anyway, that's what we have to do to access our secrets. The whole point of these secrets, again, are so we don't send them to GitHub, but sometimes we do need to access them in our own code in development that's running and in production. So that's the library we have to use.
So what happens when we do send it to GitHub and we try to actually like launch it? Like, because we have that env dot on git ignore, is there something else we would have to update on the code?
GitHub also didn't have your database URL. How did you handle that when you wanted it to run on render?
I think we included it inside of when we created the database on render.
No, go with the first thought you had. That was right.
I'm not sure.
The environment variables in render you specifically had to include. So you're going to have to do the same thing for JWT secret. But we'll do that tomorrow with deployment. It's probably a good stopping place. We're going to definitely have another day or two on authentication by itself, probably. Other questions? Okay. All right, let's do breakout rooms.